Some more U-substitution examples. And this is the antiderivative of 4x divided by the square root of 1 minus x to the third. Oops, rewrote it. Made an error, should be 4x squared. Excuse me. All right, 4x squared. So remember, we want to get this in the form of u to the n du. So we've got this radical form, so we always try to change these into exponents. So what I'll do is exponential form, excuse me. So that's the first thing I'll do. So I'll rewrite this as the integral of 1 over, and this is going to be 1 minus x to the third, and the square root is the 1/2 power times 4 x squared dx. And then we got our u to the n du, so u is on the same level as the differential, so we got to move this up to the top. And we do have this, I forgot to do this, I usually do this the first step, but I'll put this, use the constant multiplier rule and put that 4 out in front, so now we have 4 times the integral of 1 minus x to the third, and that's going to be to the negative 1/2, because we brought that up. Don't forget to change your signs. And that's going to be x squared dx. Okay, so now we have to figure out what we're going to let our u be. And it's usually whatever's to the power, because it looks like n is going to be negative 1. So we're going to let u equal 1 minus x to the third. So now I can rewrite this. 4, let's go into our u color. 4 times the integral of u to the negative 1/2, all right, x squared dx. Okay, now again, our differential doesn't match our variable here, so we have to match that up. So we need to get a du, so we'll go back over here and take the derivative both sides. That's going to be du, and that's going to be negative 3x squared dx. All right, and x squared dx, oh, sorry, this is supposed to be my x color. Keep these consistent, excuse me. And this is almost the same except for a negative 3, so I'll just divide both sides by negative 3. And I have negative 1/3 du equals x squared dx. Okay, let's take a look at that. Had to let baby outside, so give you a little chance to take a look at that. So now I've got perfect match. Okay, so now I can rewrite this as 4 times the integral of u to the negative 1/2, and and I can put my negative 1/3, and that's du. And I can put that negative 1/3 out in front, so I've got 4 divided by, and again, we can put the negative anywhere, like that if you want. Put the 1/3 in the third, 3 in the bottom, of course. U to the negative 1/2 du, and we're all set. Now we've got u to the n du. So that's just going to be equal to negative 4/3. And this is going to be, if I add 1, this is going to be u to the 1/2. So that's going to be u to the 1/2 divided by 1/2 plus c. And we can rewrite that again. We can invert and multiply. So if you divide by 1/2, it's the same thing as multiplying by 2. So we've got negative 4/3 times 2 over 1 times u to the 1/2 plus c. And then we have equal to, and then we have nothing simplifies, so we've got 8/3 negative 8/3. Okay, and that's going to be u to the 1/2 plus c, but what was our u? Our u was 1 minus x cubed. And there's your answer. Now you could write this one in radical form. That's what I was thinking about in an earlier problem. That could equal negative 8/3, and that's just like the square root of 1 minus x cubed plus c. And there you go. So there you go. That's a pretty decent problem. Hope that makes sense.